Okay, iodine can be used as an antiseptic. And we have two products, product A and B. So A, which product contains the greatest mass of the iodine from that two? So what you have given here is the unit of the 28% weight per volume. So again, percentage weight per volume means that it's either be gram per milliliter or times the 100%. A lot of times to give it to. So in the way of thinking about that, if we have it for A, the 28% weight per volume, the way you can interpret that again is, it means 28 grams in 100 milliliter, which is the same meaning as well too. Does it make sense to all? Okay, so in 25 milliliter there, it must be the quarter of the value. So 28, the formula would be 2800 times that, or using the mass here. So as the concentration is the mass of the volume in general concentration value too. Yes, this could be N over V, but I'm just talking about general concentration. Remember that it's all about amount divided by the volume. Amount could be amount or mass. So in terms of that, to find the mass, would it be what? The concentration times the volume that we have given here. That would be 28 on 100 times that to the given of the 25 milliliters. Then you get 7 grams of the iodine for product A. Okay, same for the product B. The product B is then, we do the same, mass of the product B, the B must be the concentration times the volume in case of this two. That we have given 4% of 4 on 100 times that, 500 mils. It's our total givens to, it gives us that 20.0 grams then too. So 20 grams for the B, 7 grams for the A. Easy, okay? B, which product offers the best value for the money then? To calculate the best value here, we got to understand like it's 7 gram costs about $4.10, whereas 20 gram values that $12.80 too. So let's find the in grams per the dollars. So the value, question B, the value we can find here for the A is basically for 7 gram, it's given the 7 gram for the $4.10 then too. So 7 divided by 4.10 will give you that approximately 1.71 gram per dollars. Okay, so in $1 you can buy this much of the iodines. B would be 20 grams for the $12.8 too. So that would be 20.0 divided by 12.8, which is approximately giving you 1.56 gram per dollars. So which is better? Product A is the better value than product B. Due to that, in the $1 we can buy 1.71 grams of iodines. This can only buy 1.51 grams. Okay, so your answer must be in the details and just justify with the calculation. This is the whole point. Okay, everyone can say, hey, product A is better. But not everyone can say, like, show all the required working out like this too. Make sure you do that. I've been emphasizing quite a lot. Next one. We have the molar concentration saturated copper sulfate. So CuSO4, by the way, the small letters, should be a typo, and 5H2O solution that contains 20 grams of solute in 100 grams of water at 20 degrees Celsius. So it's given that we have a CuSO4 with 5H2O. This is basically known as hydrated copper sulfate. It means that in each of those particles of copper sulfate, it contains a bit of water molecules into it, which means it's not a really pure copper sulfate because it contains a bit of the water. So what do we have to do is, it's given that mass of this is given that as 20 grams. It's given, okay? Volume of the whole things, skip that, is given as the 100 grams, which is equivalent to 100 milliliter, as we understand that the density of the water is 1 gram per milliliter like this too. Does it make sense to all? Okay, this is how we use it. We really know that the volume of that is the water is always be the always be equivalent to the mass of that as well too, due to the density. So we are given the 100 mils, which is basically 0.1 or liter in the units that we're looking for here. So what do? We actually have mass per volume, which is gram per liter volumes too. But what do we need to do to convert it into the moles? Remember the N is always B, so copper sulfate 5H2O, from the given mass of that, would it be always be mass over molar mass like this too. Given the mass of 20 divided by, show all the relevant working out guys, showing that copper 63.55 plus that 32.07 for the sulfate, 4 times, it's actually the 9 times of the water, so we have a 9 of the 16, 4 oxygen, 5 oxygen, plus that 2, 10 of the 1.08, like this. Yep. Okay, can you get like why I'm writing all that? This is the copper, this is the sulfur, this is the whole oxygen values too. We have 4 oxygen and 5 oxygen, in total the 9 oxygens. We also have 10 hydrogens given too. Then the number of moles that you're to get is approximately like 0.0801 mole will be given. Approximately. You may use the exact value, I don't mind using that. It's actually preferred using this, but after that, use the symbol. This is the what? The symbol for the molar concentration. So make sure you can use that. The 5H2O is therefore, the formula for the concentration is, Daniel? C equals to? Formula for the molar concentration, C equals to? Moles over volume, so N over V. Make sure you show that. This whole set is included in your marking criteria too. So N, we found that 0.0801, divided volume, 0.100 like that. So, and then you're to get, just divided those, 0.801 in 3 suffix mole per liter for the final answer then. What I'm writing down here in the board is required working out. I really mean like you need to show all the required working out. As I've been saying, like chemistry teachers are really picky markers. We are really strict on to the working out all the times too. Good wisdom? Good. 13. A cleaning product distributor has warehouse storing 180 containers of the oven cleaning solutions. The volume of each container is 25 liter and the concentration of sodium hydroxide is 1.65 mole per liter. Okay, 13A. Calculate the mass of the sodium hydroxide in each containers too. So, given that we have volume of 25.0 liters too, and the concentration is, or you may just say, for the sodium hydroxide, concentration sodium hydroxide is given as 1.65 mole per liter, like this. What do we need to do? We can't find the mass directly from here, so that we have to use the formula N equals to CV. So N of the sodium hydroxide, just be specified that we are looking for this, is therefore 1.65 times 25 liters given to. This will give you that 41.25 mole. Everyone good? Then what do we need to do? The mass of the sodium hydroxide would be N times the molar mass given. That would be, given the whole thing down here as 41.25 times that. Sodium is 22.99, so 22.99 plus 16 plus 1.08. Okay, and you're to get approximately be like 1,650. Yep. In 3 suffix. Yep. 1650 grams in 3 suffix too. Yes, suffix it matters too. So as I'm showing you here, make sure you show all that relevant working out. I really mean like you need to do a practice too before the term starts next week too. Like you're probably going to start with these kind of calculations too. I hope you found those easy in school, to be honest. And then you got to move it on to the more advanced stuff later on too. B, calculate the total mass of the sodium hydroxide in the 180 containers. So we have 180 containers, so each of the container contains this. So we mean that that's per container, this much of the sodium hydroxide. So the net or the mass of the sodium hydroxide. This is basically fancy symbols that I'm using, but you don't have to use it all the times. You may just say, or the mass of the sodium hydroxide total is simply be what? 160, 50 times D, 180 containers. That would be what? 29700 grams. Approximately this is the same as 297 kg. Don't have to show the unit conversions to you, but since I don't really like to have in the really long units, or you may just use the some scientific figures, 2.97 times 10 to the power of 1, 2, 3, 4, 5. 5 grams like that too. I actually prefer this method than kilograms. Okay. C, concentration. Let's find in gram per liter. So how do we convert the unit? We have given the C, the molar concentration is the sodium hydroxide. I'm just writing down 1.65 mole per liter like that too. Okay, and we also given the grams of that. So you can either use any of those. It doesn't really matter which one you use to. So first method is we use the amount of the mass you're given and then divided by the volume. Simple as that. So means that this basically mass of the volume in case of this that we have given 1650 grams divided by given 25 liters like this. Then you would get the 66.0 gram per liter. You can do that from the given values too, but it doesn't really need to show. But in a case you don't really given the grams of that too, if you want to convert the mole per liter to the gram per liter, what do we need to do? We times that molar mass of that too. Okay, so in other words, just 1.65 times that, then divided by the volumes, you would get the volumes too. Okay, D, the volume of the solution remaining in one container that has been used in 8 liter. A worker adds deionized water to container to make the backup to 25 liter. What is a molar concentration of these diluted solutions? So one thing that you need to understand about dilution. Now, during the dilution process, one thing is the mass or the amount of the solute has always been remaining same. Okay, so we are using that. If we have like say 1 liter of the 110 grams or something there too, if we dilute it to the 2 liter by adding some extra water, you still have 10 grams of that. So basically same as if you found that your, like let's say your fizzy drink is so sweet, you decided to like dilute it with extra water. But it doesn't mean that you are consuming less sugar. At the end, you actually get the same amount of sugars too. But it just makes you easier to drink it. So the formula for the dilution, as you know, therefore, as the N is the same, we're using the C1V1 is the same to C2V2 like this. That concentration of the V1, this is what? N of the total amount in the given 2. So a lot of time we are using that to find the concentration. Now, we can use that formula for the question D then given. So 8 liters remaining means that we still have the same moles of that. So you got to understand the question here. That has been used in 8 liters, and worker added the water it contained to make it back up to 25 liters there. Okay. So one container that has been in use is a liter. Okay. So you got to think ahead. Initially, think about what you have given. You're given the volume, so V1 of the 8 liter in the container. That's a remains. And the concentration, C1, the initial concentration in the really concentrated big container is same as the previous one, 1.65 mole per liter. Okay, so in other words, you have a container there. Someone used it to only be like 8 liters remained. But it doesn't mean that the concentration changed because we just used the 8 liter, we just rest of those and remained 8 liters there too. And from here, he diluted to what? To the new volume of making that to top it up with the 25 liter. But this now or to change the concentration, yet still having the same amount of the sodium hydroxide given to. So, question asking you C2. So what do we use is using the C1 V1 equals C2 V2, just using that C2 equals to C1 V1 divided by V2 straight away. Showing that because we understand this is the number of moles and divided by new volume given, the C1 1.65 times 8 divided by new volume of the 25 liter like that. Then your final answer should be 0.528 in 3 weeks. Yep, makes sense. Okay. Okay. One thing that you have to be careful with these type of questions is sometimes the question can trick you like, hey, we added up extra 25 mils. That's not saying that we're making the 25 mils. They can say like, oh, we added 25 mils extra. Then the total volume is not a 25. You got to add it up to the extra 25 to the up to the 8 mils too. Just be careful. Read the question very carefully for these. Oh, good. Okay. All right, let's try some limiting reagent questions then. These are practical questions. I'm sure I put some here. Not these ones, sorry. Going back to the questions. Did I put the some? Thought I did, but not really. Okay, no limiting reagents. Let's do some easy questions then. Try question 1, 2, 3, and 4. The 4 questions, some stoichiometric questions then, please. Now, try to do that within 15 minutes. I give you like time limit for those questions. So make sure you write it down all the record working out, but attempt the question within 15 minutes. Start now. All right, Daniel.
Do I need to say because this element is fully reactive?
For which question?
Question 3. Like it says lead nitrogen is axis, but do we need to say that potassium iodine is fully
It's really, yeah, the meaning of the excess means basically there's no limiting reagent, but you don't have to say anything. Unless we know there's a limiting reagent there. 4 minutes finished. That's good. Okay, question 1. How many moles of sodium carbonate are needed to react with the 50 mils of 2.21 moles of solution of nitric acid? A simple stoichiometric question. You're already given the balance equation, so guys, you need to know how to balance that. You need to know the states. So if you have any questions about states, we can talk about it a bit later, student. But it's given that we have a sodium carbonate, all the given. So let's start with the given information of the nitric acid. HNO3 is nitric acid. You're given the 50 milliliter. Convert it into the liter form, which is 0.0500 liter, first of all. Concentration of the nitric acid, HNO3, is provided as 2.21 mole per liter. Now, you don't have to write it down, all that information. It's more like, for me, a ritual. Like, I just write it down so that I know I would not make any mistakes from that too. Because I will find this by using the N equals to CV, the formula. But by writing these here, it's much easier to just copy those two values down, rather than you think in your head, oh, 50 mils, 0.05. And there's a chance that you made a mistake too. And I don't really like to have a mistake that from the beginning of the questions too. Then you to get the whole things would be given that as 0.1105 mole, first of all given. Okay. Now, question is specifically asking you that how much of the sodium carbonate is then required. For that, then we have to use according to the molar ratio, or you may say the reaction ratio of the sodium carbonate to the nitric acid, which is given that as 1 to 2. Then you can say N of the sodium, therefore the carbonate must be, so that bracket, then you to get the half of the N of the HNO3 like that. Make sense? Then that would be half of that, 0.1105 divided by 2. Then you to get 0.05525 mole of that too. If your question asks you to find the mass of that, you can just times the molar mass of it. It's a simple question, you can get it from that too. Any questions? Easy, like some stretch warming up question? Yeah?
Can I just write it as like that, or do I have to measure it?
Oh, sig fig, sorry. Preferably 3 sig figs for this case. 3 mole and in 3 sig figs then. Good. 2. What volume of the 1.47 mole of the hydrochloric acid solution is needed to react completely with the 2 grams of zinc? Again, no limiting reagents. It's an access to simple like a stoichiometry. As I said, it's a good warming up. The mass of the zinc is given as 2.0 gram. It's given. Okay, so what do we do from here is we can find N of the zinc. N equals to mass over molar mass. That we're given the 2 grams of the zinc. Molar mass of zinc from your periodic table, you would find that it's a 65.38. Yep, then you would get the approximately the number of mole of the zinc would be 0.0306. 6 mole like that too. Or I don't mind if you leave that in exact value of this as well. It doesn't really matter. Like I actually prefer using the exact values a lot of times. Then what we do is we use the mole ratio of the, what do we have? The zinc to the hydrochloric acid. What is the ratio? Is that 1 to 2? We're to get N of the hydrochloric acid, therefore what? The 2N of the zinc will be given to. It's the same as that 2 times that, I use the exact value, 2 over 65.38. More like that. So we're given now N. What do we do from here? What do we do from here to find the volumes as the concentration equals to N over V, then volume of the hydrochloric acid must be, just switch that, N over C. That would be 4 over 65.38 divided by the whole concentration of the hydrochloric acid given 1.47 like this. That's more like the exact value you would get, then you'd get 0.0416 liter in 366. Okay, easy. Yeah, just no limiting reagents, pretty straightforward questions then. 3. What mass of the lead iodide is formed when 25 mL of the 0.492 mole per liter solution of potassium iodide is added to a solution containing excess lead nitrate? So excess means that yes, we get the some of the amount of the huge amount, so we don't have to worry about the limiting reagent again too. So where should we start with? We got to write it over here. Question 3. Started with the volume of the potassium iodide. You're given 25 milliliter using a pipette. That's basically 0.025 liter. Okay, concentration of that, the potassium iodide, it's given 0.492 mole per liter as well too. Again, then what we can do is you can find the N of the potassium iodide by CV. That would be 0.492 times 0.025. That's giving you out that the value of the 0.0123 mole, given that too. Easy. Okay. So after that, what we do is we got to use a mole ratio. So according to the mole or the molar reaction ratio of the lead nitrate to the potassium iodide be 1 to 2. Then N of the lead nitrate must be the 2 times the half of the N of the potassium iodide. Make sense? That would be same as the 0.0123 divided by 2. Then you'll be given 0.00615 mole. Will be there too. All good? And then what do we do? The mass of the therefore lead nitrate.
Wait, are we getting the mass of lead
Lead
iodide?
iodide. Same ratio, yeah? Like that. Lead iodide. Lead iodide. So lead iodide, I2. So PbI2, PbI2. And PbI2, yep, PbI2. So it'll be N times the molar mass, say it's the same moles, 0.00615. That times that lead iodide, show all the relevant working out for the lead. Lead is 207.2 plus that 2 times iodide, 126.9 like that. Your final answer should be therefore 2.83 grams in 366. A4, A3. A4? Possible the calculation. Yeah, it would be A4. That value is rounded up. 84 grams of the lead iodide that we produced then. Good. Question 4. Water is added to the 50 mils of the 5 moles per molar of the hydrochloric acid until the total volume is 250 milliliters. What is the molar concentrate hydrochloric acid in the diluted forms? Fairly easy questions. Use the C1, B1 equals C2, V2. Identify which is C1 and V1, each of those two. You can write it down if you like to, but one thing that you need to be aware of these kind of dilution factors, you don't have to convert to units. You don't need to. Even if you do it, you get actually the same answers too. I just proved that again too. Concentration 1 is same as that, given that 5.00 mole per liter. V1 is given as 50 milliliter. Now, if you want to attempt to like change that to liters, it would be 10 to the power minus 3, liter 2. Okay. V1, V2 is given at 250 milliliters, basically same as what? 250 times 10 to the power minus 3 liters was 2. You're asked to find the C2. So C2 is C1 V1 divided by V2 here. C1, which is 5, V1, which is 50 times 10 to the power minus 3, divided by 250 times 10 to the power minus 3. So you see that these two are cancelled then. Therefore, you get the same answer when even if you're using the milliliters there. Then the final result would be just 1.00 mole per liter then. Easy, okay? So it's been a while, like we did some of the dilutions too. We actually did that kind of early this year and the last years too. So I hope that give you some revision of the concentration, molarities, stoichiometry. We haven't done any limiting reagent questions yet. That's something we're going to do after we have a break. But any questions? Anyone? Luke, you good? Claudia, good? All right, let's have some stretch, have some break. This is called the back titration process. I know it looks really complicated. You'll be wondering like, why so many like plus and minuses there? Why isn't it just the completed forms? Well, you will get it. You will actually get some of the plus and minus, like electrons and ions kind of combined the two. But one thing is that you do not need to understand why we get these positively charged all that too. You don't need to understand anything in here. Okay? But one thing that you need to understand is the why all those processes going on too. So let's read, and I will provide you the flow chart of this, what's going on in here. So aim is that the manufacturer requires that its product contains at least 85% volume for volume ethanol. We learned it, didn't we? Okay. The concentration of ethanol in water can be determined by back titrations. Ethanol is first oxidized with the ethanoic acid using the excess acidified potassium dichromate. Now, don't worry about it, which simply means that, hey, this is ethanol, okay, and you go through a reaction look like this. That's all you need to understand. Then, the remaining dichromate ion, which is dichromate is this one. This is a dichromate. Ions are reacted with excess iodide ions to produce iodine. The reason for that is this. We have given some of the ethanol. So you got to understand here. We have an ethanol. Okay. What they do is they add some the dichromate into the ethanol too, making this to be reacting. But one thing that we all know is this is with the excess iodide ions to produce iodines too. So remaining dichromate ions indicates that this is the in excess. Does it make sense? It means that ethanol must be your limiting reagent. The limiting reagent will be given to. So after we're mixing this ethanol to that too, you can understand this is producing that some product, which is the, it's given here, just follow to the given information here, produce the ethanoic acid. Okay, and with some excess, there'll be some excess dichromate is left over too. Any questions up to you, like for the first reaction here, what's going on in the chemical reactions? Secondly then, what we do is, to determine the dichromate, the excess iodide. So what they do is they're gonna add some excess the iodide into that given mixture there too. Now you gotta understand the purpose of the adding the extra substance there too. This was to identify ethanol. First of all, how much ethanol is given. Then this is then we want to get rid of the understand how much of the dichromate was used, or in excess using the excess iodide given. Then what does do? Those iodide what produces then titrated from here, because we understand the iodide here producing the I2, producing that. Does it make sense to all? So what comes after is that we have some iodide, there will be some I2, sorry, there's I minus, my bad, I minus I should say, and I2 is produced, okay, with some excess, remain the I minus inside of that too. Make sense? Once coming after that too, you are titrating. Titrating means that you're doing some experiments to get the exact amount of those iodide, and the reaction is given here. The sodium thiosulfate or the thiosulfate reacting with the I2, can you see the relation between here? It goes to this side over here and producing those until you get reaction. And this is the volume of sodium iodide, sodium sulfate that we use in the titration process. Okay, so let's read this part then. 25 ml of sample of the manufactured product was diluted with the distilled water. So I will start like here. Show all the relevant information here. So assume that we have 25 ml of the some product that we give it. What we do, you dilute it into the distilled water to 1 liter. Does everyone understand? So what happens to the dilution? Ellie, what happens during the dilution then? If we dilute 25 ml to 1 liter, what happened? The volume increases. What happens to the concentration? It's so lower the concentration or changing concentration. What about number of moles? Doesn't change. So there's no change in the end. There's something you need to understand from the given point over here. And this is what this article, like, it's some good exam strategy to understand what's going on. Rather, you read that 3 or 4, 5 times during the exam time. Draw a diagram, draw a flow chart to understand, to summarize the point. It will save you time. I really mean it. It will save 10 minutes. More than 10 minutes of time to times 2. And then 1 liter is given. So the 25 ml aliquot dilute solution was added to 20 ml of that. So you have to understand, 25 ml aliquot dilute solution means that from the 1 liter, you're taking out small conical flask of the 25 or milliliter of the aliquot. The aliquot means that sample from the taking out the 25 ml from the 1 liter. Okay, wisdom. Is there any change in concentration if I'm taking 25 ml from the 1 liter then?
Yeah.
No. Simply, I have a batch of 1 liter. I just took the 25 ml out. I didn't dilute it. I took the 25 ml out. So, which means that there'll be no change in the concentration. Okay, but what about the number of moles? Obviously, if they're sharing the same concentration, this would have that less number of moles too. And there will be some factors of those. Guys, it's a very simple question. If we say, hey, in 25 ml, let's say we have 1 mole. In 1 mole there. Look, if I have 1 mole in 25 ml, how many moles would it be in the 1 liter if they're in the same concentration? 40 moles too. As you know, understand that it's times 40 in terms of that. Why? In 1 liter, there are 0.025, giving the 40s like this. Which simply means, you got to understand here, if I have 1 mole in that, or say just 1 molecule, 1 particle in the 125 liters too, in 1 liter must have the 40 of those too. Does it make sense? Mister, does it make sense? Daniel, make sense? Okay, so we're given up to here. We got 25 mils of liquid, and we're given that. And so we're going back in later too. Now, this was added to the 20 mils of the 0.50 mole of the acidified potassium dichromate. So what we have done is they added some the dichromate Cr2O72 minus. Let's write it down. It's given that 20 milliliters. Okay, and with the concentration of the 0.05, let's write it here, 0.500 mole per liter, also be given as 20 milliliters added. Can you see what I'm doing here? I'm trying to summarize all the points in this diagram too. So we added there. What do we expect? This is something that you have to understand. It will be in excess. And we designed to make them to be excess. So we are giving some extra amount and put it over here. So what happens then, as we want to discuss that, the liquid contains the ethanol. It will reacting with this dichromate first of all. Okay, but as this is an excess, remember that this is excess, means that all of those could be used up as a limiting reagent. We get certain amount of this we left over. Make sense? Okay. Then what do we know? Then acid and sulfonic fluoride potassium iodine. What happens then after is this after we get the some. You can think about here. We have added some total volume now 45.0 milliliter. As we add up 25 and 20 mils to get us to. And in here we have the excess. The dichromate is now in there. All good? Then what we have done is you added some, the 2 grams of the potassium iodide of the, which is 2 grams. And this is again in excess of that too. So what do we do is we are going to cancel out all that dichromate using this. And at the end of that, this is now be producing that forms of the some conical flask with some remainder of I minus remained inside of that too. And what we've done is you do the titrations with the burettes given to. Inside of the burette there are solutions of the sulfate S2O3 minus 2 minus, which is 0.900 mole per liter like this. And then this is the result. After we're adding up, we're getting this much of those we're used to. So for each of those, what we're going to do is, this is step 1, 2, 3, 4, 5. We're going backwards. We've got to start from this steps over here, step 5. Think about the purpose of the step 5 first of all too. Why are we titrating with the diethiosulfate with this one? This aim of this here, aim of the this process is to determine the I minus that's remained. We would like to get that. Or I2 that is actually produced. And then one thing that you have to understand is this. In any of the chemical reactions, remember this magic formula. N of the total is always be same as N that it is reacting, the reacted plus the N that is in and the remained after the chemical reactions too. Okay, the same as like, hey, I used to have, I'm thinking this way, I used to have $10 in my pocket. Okay, I bought something, I realized that I have a change of $2 in my pocket now. Yep, remember that I used to have a 10, now I have a 2. How much did I spend? Easy. Because you know that, hey, from the total amount you have remaining debts over the $2. It's obviously you use the $8 too. Now, back titration is basically using the exact same concept of that too. That we are looking for how much is reacting from here. So let's start the calculation part. It's going to be a really long calculation, by the way. Okay, so what do we do? From the volume of the 1, 2, 3, 4 of here, should we count the first one, the 29.9? Remembering that we do the rough titrations, this is not get counted. So let's calculate the volume average for the what? The S2O3 2 minus, started with that too. To calculate that, you show all the working out, so 28.7 plus 28.4 plus 28.6 divided by 3 as the titration. 1 is an outlier. Okay, so calculating that, you're to get the 28.5667 milliliters first of all. Okay, some of the exact values that were given. Then what do we know? To find the N of the S2O3 2 minus, what do we need to do? N equals to CV. Concentration, you're given. This is why I asked you to write all the relevant information in the flowchart here. Is 0.900 given too. So it's simply 0.900 times that. Milliliter into the liters, so 28.5667 times 10 to the minus 3 like this, convert to units. Then you get the number of moles, that would be 0.02571. Make sense? Okay, so we now know this is the amount of the remainder too. So what do we do? Use the reaction, guys. This is amounts that we used for the thiosulfate. Then we would know I2 would be something fall into the reaction ratio, stoichiometrically too. So according to the reaction ratio of the S2O3 2 minus to the I2, it's basically so that we know that N of the S2O3 2 minus, as they are given to 1 to 1, same as the N of the I2 that is used remained in the first reactions. That would be, oh, actually 2 to 1, wasn't it? 2 to 1. So, yeah, 2 to 1. So that would be what? Half of the N2 of that will be given to. So that would be half times that, given 0.02571. You're to get 0.012853 mole of that, this. And then just check your flow chart. This is I minus I2, sorry, I minus I2 that is formed before 2. So we're going to think of here, these two are related. We found that this is now be 0.0, just writing over here, 0.0125A3 is given. Then, going back to the second equation here, the reaction ratio between I2 and this is what? From the second equation then, we'll get N of the, use the reaction ratio again of the dichromate, that S2 Cr2O72 minus to that to I2 would be given as that 1, 2, 3 from the given. Then therefore N of the Cr2O72 minus. Now this is the Cr2O7 minus, excuse me, there are excess. So I'm going to write an excess, or the remained. It's the same as that, 1/3 times the N of the I2 given. Then that will be given as times that, these two values too, you get 0.00428 0.00485 mole will be given that. All good? Up to this part here. Then what do we know? This is amount you remained. Look, do we know how much of the dichromate we use? How much of dichromate we use? See, use the flow chart. Yeah? Do we know that? Excess, we just found it here. This is given that as 0.004285. We found it. Okay? Are we knowing, like, do we know like how much we use? Yes, we do. This is what's given. We provided some extra, so excess as an extra. You may just understand it too. So from here, we have to do this. N of the dichromate 07 initial, or the total amount of the dichromate you're given is CV here again too. That'll be 0.500 times that, 20 mils, 0.020 given. That's giving you out 0.01 mole. That's total you're given. Okay, so got to understand the point over here. You're given, first of all, this much of the dichromate. Yep. This is amount of dichromate left over. Just like you had a $10, remaining dollar is 2. If I ask you to how much they spent, you simply do this. N of the spending or the reacting is therefore found by N of the dichromate 072 minus total minus N of the dichromate that is given excess or leftover. Make sense? How much were we given? Initially, you're given this much of the 0.01. How much was left over from the titration we found out is 0.004285. Therefore, we are able to find how much of dichromate is used for the whole reaction. That'll be 0.005715 mole. This is amount of the dichromate reacting. Reacting with what? The ethanol in 25 mils given to us here. So as we now know, this is a 2 to 3. So using the reaction ratio between the two, so use the reaction ratio of the C2H5OH2 dichromate CR2O72 minus, which is given that as 2 to 3 or 3 to 2. And of the C2H5OH must be same as what? The 3 on 2 of the N of the CR2O72 minus 10. So times these of the values too, you're to get the total value of the 0.0085725. It's given then. Okay, so we just found out, guys, you remember here, we found out ethanol in here, ethanol N is 0.0085725 moles in the 25 milliliters. All right, then how much would it be in the 1 liter? Times by 40 is 2. So the N, N of the ethanol C2H5OH. So this is in the 25 milliliters. So in OH in 1 liter must be the 40 times that 0.0085725. That's a total amount of ethanol that we have. Let's calculate that value here. So 0.0085725 times 40. You're to get 0.3429 moles in the 1 liter then. Okay, so that's given. We found it here. We have given 0. What's the value again? 0.3429 in that total of the 1 liter. This is same as the moles we have in the product in 25 mils again too. Does it make sense? This is why I ask you to like draw the diagram. You have to understand. Then what do we know? Then and finally the mass of the C2H5OH is then N times the molar mass of that too. And just simply what we have practiced today times that 2 times 12.01 plus 6 times 1.08 plus 16 is like this. You get the total mass of that. Total mass of that will be giving you that diluted solutions to around that 15.797. grams of the ethanols that we're given to. Are we done? No, we have to find in the percentage volume for volume again too. So what do we know? This is the given grams and in 25 mils of that too. So this is the basic question you asked me. We given the density of the ethanol here. What do we know about the density? Density is all about this. Density is mass of the volume. So to find the volume of the ethanol, would be mass divided by the density itself. So which means if we have this much grams of the ethanol, so 15.797 divided by density of the ethanol, what's given as 0.789. It's the same value you have in your homework anyways too. Then you get the volume of the ethanol is therefore 20.02 milliliters. Okay, now what do we know? This is the ethanol in how much of the products? How much of products? 25 mils of products too. So final step is therefore, after that, you're going to do this. 20.02 divided by 25 milliliters times 100%. As we've done, I get some way for YR2, so you're to get 80.08. or approximately 80% the volume for volume. Which means the manufacturer is lying that it's not the 85% of the standard given. Ta-da! Ta-da! Yes, this is the hardest question in terms of stoichiometry too. But okay, let's be clear for here. Besides that complicated process of the titration here, now in the calculation, is there anything new in the calculation to be honest? You basically, you know how to find the average, you know how to use the n, how to find the n, you know how to use the reaction ratio stoichiometry too. It's a matter of the way to use it. It's complicated, I know that too. But besides that complicated process of the titration, the working out itself is somewhat very similar to what you practice in year 11 for now too. I mean, we learned that in year 11. We're learning that in module 2. We're learning that everything in module 2 too. Even that is kind of new, but you can understand it quite easily too. So the reason why I picked these type of questions the hardest in the year 12 is, one, students forget about how to do with the stoichiometry properly in year 12. Because we don't really get a lot of stoichiometry questions, to be honest too, but we do get in HSC examinations. So more you practice and more effort you put in for the practice for these kind of harder questions, I think it's really worth it. Because you have a time to prepare for those for a year and a half actually. A year and a half is a good amount of time to master those skills of the titration as well as stoichiometry as well too. So guys, make sure you do it. We actually started learning the stoichiometry from last year. So for you, it's more like 2 years of preparations. And the reason I started with the module 2 rather than module 1 is this takes time to understand. This takes time to practice. Module 1, come on, just need to memorize some theory space behind them too. If someone doing the module 1 test in the schools too, I don't think no, it would only take about a week or 2 to finish the whole module 1 contents. But this, you can't do that in a week or 2. This takes about a month to 2 or sometimes go up to 6 months. Okay, the reason why I share with these questions first, don't worry, you won't get that question. Don't worry, yet, not in year 11. But when you start in your year 12, they're going to pop up these kind of questions a lot. Collingwood, be prepared. You guys had a really fancy questions this year. I told you, this school, that school is kind of crazy. They combine all mod 5, 6, 7, 8 for term 1. So we need to try for it. We need to master these things too. Don't ever think you have plenty of time. You don't have much time left. Yes, wisdom. This is what we're doing right now.
You
Yeah.
You're grinding this in 2 weeks for me, but you said it takes up to 6
Yeah, but early the better. We're starting it now. I mean, up to there is taking us 6 months. Up to there. By understanding this, okay, tell me, is there any like issue with understanding this one? Just the calculation parts. No, understanding this one.
I do get confused with
Yeah.
the ratios. So for example, if it's 2 to 1, right?
Like here, 3 to 2, yeah.
Not just even 2 to 1.
2 to 1, yeah.
After when I write that line,
Yeah.
and then I write the next line, it's like, oh, therefore, n blah 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 equals.
Yeah.
I don't know either if it's like I times it by 2 or if I divide it by half.
No, you do this mathematically. You solve it mathematically. So how do we solve that in the ratio of forms to? You times that in the middle, in the inside, and the outside. So what do? You know that 3 times CR2072 minus is same as the ratio of the C2H5OH. What do we do if we want to get to the this one here? You divide the 2 on both sides. Therefore, you get 3 on 2. I just do that quickly because I've been, I've done many questions about this one too. So I have done a lot of practice. So in my head, like just seeing that, oh, it's got to be 3 on 2 straight away. But if you're not too sure, same for you, Daniel. Like if you're not too sure how to get this straight away, don't attempt to just don't assume. Do not assume that, oh, I think it's got to be 3 on 2. I have a feeling this is got to be a half. No, solve it. Use your muscle memories to solve that. So that divided by 2, you get what? 2 cancelled on 3. Yes?
Can I just say, like, for every 2 molecules of CR207, there's 3 molecules of C2H5OH?
Say it again. Sorry.
So, okay, for example, if I was doing, like, sulfur trioxide, I think.
Sulfur trioxide.
So for the first one, like how S2H3
Yeah, 2 to 1, yep.
I2 is 2
Yep.
to 1.
Yep.
So can I just say like for every I2 there's 2 S2H3?
Yeah. Yeah. That's what I mean. That's a ratio. Okay, basically same as like, do you remember like the recipe of the making the sausage sizzles? Basically the same thing. We only need a 1 bread for the 1 sausage, okay, basically, or 2 breads. Okay, or like, I don't know how many onions you're gonna put it in there too. Making the cookies, like basically the same. Okay?
For the one you were showing me, right?
Yeah.
If it's 3 over 2 for...
What? Yeah. Yeah. Okay.
No, but I don't get it.
What do you mean you don't get it now?
Like, okay, for example, for iodine, right? That one right there.
Yeah. Okay, let's go for the easy one then. That's confused you. I know stoichiometry is kind of confusing time to times, but what you have to overcome and move on over this hurdle. Okay, let's think about one reaction, H2,5OH ethanol reacting with the oxygen gas producing CO2 and H2O, complete combustions of that two. Balancing that, kind of easy. Start with the carbons, 2 of that 2. We have a 6 of that, having a 3 of those all together 2, and making that to be 2, 4, 3, so we have a 3 of those. Balanced. Okay, we've got to understand here, if I have 1 mole of the C2H5OH, how many moles of the oxygen we require then?
2.
Yeah, easily get to 2. But if we're using some mathematical here, use the reaction ratio, can we do that? OH to the O2 is 1, 2, 3. What do? I ask you to solve that mathematically. If you're not too sure, solve it. Just don't assume it. Then, what's the product between O2 and 1? That'll be NO2. Okay, what's the product between 3 times that?
3.
Yeah, 3 times N of the C2H5OH.
Yeah.
So if we have 1 mole, I'm thinking here, I ask you to how many moles of the O2 required at A2. So can we say N of O2, so if I have N of the, say, C2H5OH, let's say it's 1. Yep, we have 1 mole of that. Just solve it mathematically. Substitute the value here. What do you get for the NO2?
1, 3.
Yeah, thank you. Now, is this matching to our understanding? Yeah?
Yeah.
Yeah.
I don't understand when it's time for it to be like fractions. Like 1/2.
Okay, what about now? Guys, you can try it again. I have given 1 mole of the O2. How much of the CO2 then? CO2 produced?
1/3.
Oh, how'd you get that? Are you sure? 1/3. See? Don't assume. Don't assume. This is what I mean here. Don't assume. Don't calculate in your head. No. CO2 produced. You got to do math, some work. I need to see some work. What do we do? N over O2, listen, tell me, N over O2 to N over CO2. Tell me the ratio.
3 to 1. Oh, CO2, 3 to 2.
3 to 2. 2. No, O2, CO2. Give it. What do we do? Solve that. So N 3 times N over CO2 is same as the 2 times N over O2. What did I ask you? I asked you to find the CO2, yeah? So make the subject CO2. So N over CO2 is therefore 2/3 of the NO2 given. What do we know about the N over O2? It's 1 mole. So what is that? Same as 2/3 times 1. So if we use 1 mole of the O2, you produce the 2/3 of the CO2 then. If you don't really understand, don't need to. Solve it. I mean, like, just do some math work until you understand it. The worst habit you have is, someone needs to listen to this basically, okay? Is you sit down until you understand. There are some people like that try to sit down and try to like look into the question like, oh, I don't understand, I don't get it. Move on, do some work, okay? Move your ass. I really mean it. Just do something like use your muscles too. Because, studying a bit of neuroscience, stimulating your muscle actually activating your brain cells as well too. Rather than you sit down and just try throwing that and just try to understand, no, it doesn't work. Sometimes use your fingers and your extremities muscles too. And you will actually activate your brain cells much better too. It will come to the moment that, oh, I finally understand. Yes, Mr. Try that. I mean, really mean it. I recommend it too. If you don't really understand, don't need to. Just do it. Just do in this method too until you actually want to get it. Same for you, Daniel. Like this is basically a question you asked me last week too. If you don't really understand like why the ratio is working too, you don't have to. Just do it. Like this mathematically too. If we are solving a mathematical question rather than chemistry questions, this is what like year 9 questions then. I really mean it. Year 9 mathematics. I think year 9 is doing the ratio values from the year 9 and 10.
I never did ratio.
You never did the ratio?
No.
Does anyone do the ratio here? No? No one? Also, I have to teach for me. Okay. Okay. Guys, sorry. Okay. I thought it was like, okay. I told my student year 9. Okay. Guys, ratio, by the way, 8 times that, the one in the bracket first and that, and you write it in this method too. This is basically the rule of the ratios. Sorry, I didn't know you didn't learn that too. But this is the rule that you need to know. Do some math after this too. Okay? I'm surprised. Did it change the syllabus? No. Okay, again, just going before we finish the question there. For any of those kind of really complicated process questions, draw the diagram. I really mean it. Draw it. And okay, one more thing. Did you know that you're allowed to use a highlighter or the highlighter for the exam questions only? You're not allowed to write it in your answers, but you can highlight it like this. Use the highlighters too. Use it. Don't miss any important information and write it down as this too. This will not be assessed when you're writing that on the top, on the bottom, or like side of the questions. But as I showed you here, much easier to understand the questions, and so that you don't have to read that through again. Tell me how many times you read through these the whole things. Wisdom, how many times did you read these questions? 3 times. Now think about time spent too. Guys, examinations are all about time management. I really admit it. 7 marks in the HSC means that you only have approximately like 10 minutes. Yes, you only have 10 minutes, guys, and I give you plenty of time, 15 minutes for this. 10 minutes means that you need to read, you need to process that, you need to solve it to get 7 out of 7, which is really challenging. So those who are organized, those who are good at like managing your time are able to do this question. By the way, in that year 21, there are not many actually got a full mark for the 7 marker questions like this too, but band 6 mark, which is the top 10% of the students, I would say 5 out of 7. They were able to get managed to get 5 out of 7. Yes, there could be some mistakes in the calculations, they missed it out, some silly mistake, that's fine. And I don't ask you to get 100%. I never ask you what marks you should get. 80 or up, band 6. I really mean it. Try to consistently get an 80% of all too, then you can kind of boost it up. You may get over 85%. I will tell you straight away in year 12, you will get band 6, even before the HSC. I can tell you, if you're consistently getting the 80% of all too. But if I say nothing, that means something too. I'll probably say, okay, you gotta try harder. You gotta try them more. You gotta push it. Especially if you're in the boundary of the band 5, band 6. Oh, by the way, band 4, guys, is below 70. It's band 4.
Would you be sad if you got band 4?
Yes, I'll be very sad. I'll be very, very sad because I'm not teaching you to get a band 4. My standard is always be a band 6, by the way. And I really think it's achievable, it's doable. Compared to like, guys, I'm not teaching you for you English here. I can't teach you that even too. So for you English, I don't know how people get a band 6 to be honest. Like there's a girl who's doing that. I'm not, okay, hands up. For you math is different word too. So if you ever do like, I think you got to do the for you math later on too. Planning too. You don't have to get like an 80 even too, 70 or above 60, you get a band 6, E4. That's standard.
60.
Oh, 60s, 70s, yeah. Because it's a darn hard. It's really hard, really difficult. Like actually, like unless you're studying for the Math Olympiad, there's no one actually finished the paper. People who are doing the Math Olympiad, they can finish the paper too, and they found like for you math is pretty easy. So if you have friends like them too, okay, just be a good friends. Ask some math questions too. But chemistry, you don't have to. You don't have to get like, it's just 80% of all too. Physics, probably the same. Biology, you may need to get around 88, 89-ish to get the band 6. So this is why I'm kind of nagging you for bio if your answer is not really complete or not perfect. Even though you say, oh, I know the contents, I know that pretty well. If your answer is not really complete, I would say, no, you won't get the band 6, come on. There are plenty of people doing the better answer than yours. I really admit it. They're actually writing like some sort of ChatGPT, to be honest. Like this for me, like, oh wow, like come out with a lot of the details there too. Now, this is the point. You need to be a little more perfect and some of the answers to the questions too. So for the chemistry, again, working out, like this kind of working out is very important. That can decide you to whether you get the band, not even band 5, band 4 and band 5 to be honest too. Okay, so trust me, you have to trust me. You need to write all the relevant working out too. And these questions, I don't know, we may have a chance to come back to this question later, probably next year, but not this year again, maybe not. No, I don't think so. Yeah, we're going to move it on to the module 5. So we're not going to touch that again, questions too. But I will bring a very similar style of questions about the back titration, which is the practice we're going to do next week too. So you need to understand the process of back titrations, the titrations too. So next week, yes, as I said, we're going to prac and do like 2 sets of prac, maybe 3 sets, make a standard solution, all that too. So it's got to be quite busy. So titration is a process that we use in the some experimental process that measuring the exact volume required to. I can explain that to you again. Okay, all right. There are two extra questions that are attached as well too. Just try one question with that. Extra questions. I should have the extra questions there. No.
What's PKA?
Do we have PKA there?
Question 36, PKA.
Oh, don't worry about it. Okay. Oh, no, not that one. That's wrong printed. You don't have to do it. Okay, next, the page after, please. Actually lost the page. Was it this one? Okay, could you try for the questions after? So that's the sulfuric acid question, please. Oh, here you go. I found it. Yep. Not this one, sorry. The one after. Aluminium question, please. Can you try the aluminium questions? And here. Thank you. I give it about 9 marks. Doesn't need to be 9 marks. 10 minutes for this. So compared to the Beck-Titrate question, that would be angelic. Much easier and straightforward. You can see that.
Do I do aluminium as two ones? Or is just aluminium?
Is there a 2? Is there 2? Where? Ah, I don't know. I don't know. I'll probably get to know in 10 minutes. 8 minutes. Okay, aluminium reacts with sulfuric acid, H2SO4, which is an acid and automobile batteries. We have given the reaction between those two. The time stat, you gotta understand one thing, that even the question, the question kind of guiding you to find the limiting reagent, but the time that you need to find, you must find the limiting reagent is when you're provided the two reactants or the mass, whatever the number of moles of the reactants given. So to find the limiting reagent, you always need to start with finding number of moles of everything. So aluminium, N of the Al, use the formula. Check your answer, guys. You need to show all the relevant working out, please. And the 20 divided by aluminium is 26.98, using that value. And you to get, this is given that as 0.741 mole. And I just give you this is given. Amount you're given. Same for the sulfuric acid, N of the H2SO4. We do the same method of the air mass over molar mass. That is 115 divided by 2 times 1.08 plus the 32.07 plus 4 times 16 for all the molar masses given. Then you're going to get approximately 1.172 mole. Now, don't estimate anything in here. It's hard to assume, especially for the reaction ratios given here and there too. So what we have to do is, I really ask you to use your muscle memories to solve that. So for the given amount of, it doesn't matter which one you choose to. So I prefer to choosing the something simpler. So aluminiums for the aluminium. Okay, the amount of the H2SO4 required can be calculated as, first of all, use the ratio between the sulfuric acid, the reactants, and, so that would be 2 to 3. Having that, N of these, therefore, N of the H2SO4, the required, would be what? The 3 on 2 of the N of the aluminium given. Now, any questions up to this point? Oh, good, okay. Then you're to get 3 on 2 times the 0.741. Then you're to get 1.112 mole is the amount of the H2SO4 required. Compare the two, the H2SO4 given. So compared to 1.172 mole, which is the N of the H2SO4 given. By comparing that, you would know, okay, I need this much of the H2SO4, 1.112. You have given 1.172. As you can say, oh, okay, we have given more than required. So you may just say, oh, therefore, H2SO4 is in excess, will be left over. In other words, the aluminium is the limiting reagent. This is the proper working out for the writing that all the times for the limiting reagents then too. Good. B, then calculate the number of moles of the aluminium sulfate produced. So from that, what we're understanding is we got to use the limiting reagent aluminium then, 0.17 here. So according to reaction ratio, you'll use the mole ratio of the aluminium to aluminium sulfate. That's given as 2 to 1. And of the aluminium sulfate must be the half of the aluminium. Make sense? Okay, so that is same as what? Half of the 0.741. That's giving you 0.3705. In 3 sig figs, 0.371 mole then. I just try to get into a 3 sig fig all the time in case of this. Next one, C. Calculate the mass of the aluminium sulfate produced. Easy. Then C. Mass of the aluminium sulfate is N times the molar mass, 0.371. That times the molar mass of everything. Aluminium, show that 2 times the 26.98 plus that 32.07 plus the 4 times 16 is like this. Make sure you show all that as well too. Then you're to get 126.8. Yes?
Wouldn't it be 12 times 16? Yeah, because It's SO4.
Oh, 3. Yeah, actually, I missed that. Yeah, aluminium 2. So 3 times 32. Oh, you got a big value. Or 7 plus 12 times 16. You're right. Just checking the sulfur is 36.07. Yep. Then did you guys get 126.8 grams in 4 sig figs? In the 3 sig figs again, it'll be 127 grams in 3 sig figs too. Last one, D. Calculate the mass of the H2SO4 remained at the end of the reactions. One thing that you must understand that is always N of the H2SO4 in remained will always be like from the total SO4 total or the given minus that N of the H2SO4 that is in like a reacting or used. So we're given that amount given, 1.172. That's what we found out. That's given. Now, how do we calculate the required to? We did that in our calculation. H2SO4 required would be 1.112. Make sense? Okay, so what we know is total given is 1.172. That's given. By using the aluminium, as we understand that's a limiting reagent, we got to use the 1.112 in total mole of that too. So minus these two, you get 0.050, 0.060 mole of the H2SO4 is now remained. From here, simply just use mass H2SO4 is therefore and times the molar mass given. That's 0.060 times 2 times 1.08 plus 32.07 plus 4 times 16 is like this. Then you're to get the total value of the 5.89 for the final value. Gram in 3 sig figs there. Yep.
What's the same that where the unit is grams per mole?
That's molar mass unit.
I got 5.93.
9.3. Just checking the answer now.
Are you saying exact value?
5.89 should be. Exact values. Which exact value?
Like for the number of moles remaining.
That's what,
H2SO4.
remaining, yeah. So total is 1.172. And reacting is 1.112.
I use like every exact value.
Wow, okay. Oh, okay. It's got to be complicated then. 20 divided by 26.98. Oh, okay. Let's do that times 3 divided by 2. So you get 1.11193 of the values. Shouldn't be that different though. Okay. Plus that to 32.07 plus 4 times 16 and minus that. Yeah, I don't get much difference though. I get 5, okay, did you get the 5.93? Yeah, around the value. In the case, just use you can use the rounded value in case of this too. Okay, some revisions, but challenging questions again to a limiting reagent. Hope they give you some revision, refreshing your mind about how to write the limiting reagents too, and basically no problem again. So gonna finish the module 2 very kind of quickly too. Prac next week, don't miss any time. Next week, 4:30, coming back to 4:30 again, so don't miss it. We're gonna do the prac. And the week after, some little gas flows, kind of revisions too, and the yearly preparation, half-yearly preparation after that too. Not the yearly, half-yearly. Any questions for now?
So are we not going to revise the gas laws?
We do in 2 weeks.